Going to talk about is the law of large numbers. And let me just see, I said language of large numbers, it's law of large numbers. And basically, this is, even though I've been studying statistics for a few years now, this is something that I haven't heard of before. And so I found out about it when I was preparing my lesson plan for our programming. So the law of large numbers states that when the researcher repeats a random experiment many times, the average results get closer and closer to the true underlying average. So I've got two small little programs that I can use to demonstrate the law of large numbers. So the first program is we're going to simulate coin flips. So when you have a coin, you either have heads or tails. So we're going to create a function to simulate coin flips. So simulate coin flips becomes function, brackets, in, curly brackets. Flips becomes sample, brackets, C, brackets, H, comma, T. And C means it's creating a vector and it's combining the elements to that vector. Comma, size equals n, that's the number of flips. Comma, replace equals true. So you're doing sampling with replacement in this instance. So TBL becomes table, brackets, flips. So you're going to create a table of flips, and the table is going to have two columns being heads and tails. And then it will tell you how many heads you have and how many tails you have. So we're going to print TBL1, that's your first column, and we're going to print TBL2, that's your second column. And then we're also going to calculate the percentages of heads, which is TBL1. So percentage heads becomes TBL1 divided by TBL1 plus TBL2. So what that's going to do, I mean, you could have said, but yeah, TBL1 divided by TBL1 plus TBL2. There's a number of ways that you could have done it, but I just chose to do it that way. And then you have percentage of heads. So what we're going to do is we're going to have flips, and we're going to simulate the flips 10 times, 100 times, 1,000 times, and 10,000 times. And then so as the number of flips increases, the average should become closer to 0.5, because when you have a fair coin, the probability of flipping a head is going to be 50%. So for 10, let's see if we can get this. For 10 flips, head is 4 and tails is 6, so that means it's 40%. For 100 flips, heads is 55 and tails is 45, and that's 50%. For 1,000 flips, heads is 518 and tails is 482, so that's 0.51%. And then for 10,000 flips, heads is 5,003, tails is 4,997, so that's really close to 50%. So that just demonstrates the law of large numbers, that the more experiments you have, the closer to the average the mean is going to be. So I'm going to give you another example. So what we're going to do is we're going to roll the dice, and then the average is 3.5. So we're going to create a function for this. Roll die becomes function, brackets, in, and curly brackets. Rolls becomes sample, brackets, 1 to 6, comma, size equals n, comma, replace equals true. So that means we're going to sample with replacement, and then we're going to sample 1 to 6, however many times we deem we want to do it. and then we're going to print the mean of the rows. So die 10 becomes roll die 10, and then we're going to print averaged roll die 10 times, then die 10, and then next line. So we're going to do that for 10 rows, 100 rows, 1,000 rows, and 10,000 rows. And what we're going to do is we're going to print the average. So the average is supposed to be 3.5. So for 10 rows, the average is 3.9. For 100 rows, the average is 3.57. For 1,000 rows, the average is 3.543. And for 10,000 rows, the average is 3.5005. And so, as you can see, the more samples, the more rows that you have, the closer to the average of 3.5 you're going to get. So that concludes this video on the law of large numbers. And the next video I'm going to be working about another statistical topic in R. So I hope that you decide to watch it.